Hello everybody, welcome to this wonderful video where we are dealing with an interesting problem, and the problem is stating when an ideal gas is compressed adiabatically, its temperature rises. The molecules on the average have more kinetic energy than before. The kinetic energy increases. Now followed by this, we have four different options. We need to pick up the correct answer, obviously. So you can give the video a pause and think about the possible answer, and then you can continue watching. So I hope you have picked out the answer. Let's find out if it is correct. So if we go into the explanation, so we begin this way, that since it is an adiabatic process, we can say that delta Q is equal to 0. Now if delta Q is equal to 0, then we can say from the first law of thermodynamics that dQ equal to delta U plus delta W. Now in this particular scenario, since dQ is equal to 0, we can say that delta U plus delta W is equal to 0. Now in this present scenario, since an external pressure is acting, compressing the system, so we can say that the volume decreases. And since there is a decrease in volume, we can say that the work done is negative. Now if work done is negative, then we can say that delta W is equal to negative of delta U, and since delta U over here in this scenario is negative of delta W and delta W in itself is negative, so internal energy change is positive. So we can say that kinetic energy of the system or the kinetic energy of the molecules comprising the system will increase. But the problem is, in the four options, we have none of the explanation which I have given so far, but it is true. Now the question is, what exactly the problem is looking us or asking us to find. So if we think about this problem in this way, that we have a large cylinder fitted with a piston, and now the piston is compressed adiabatically. तो अब क्या होता है, as the piston is compressed adiabatically, we say that the molecules which comes in contact with the moving piston will undergo a change in kinetic energy due to collision with the moving piston, and thereby an increase in kinetic energy is taking place. Now since the problem is dealing in microscopic level, so now if we go back to the molecular level and find out the answer, so we can clearly say that because of the collisions with the moving parts of the piston, the kinetic energy is rising. That is, option A is correct. We can say that because of the moving piston, the temperature was rising, and the molecules which comes in moving parts of the piston collides with the moving parts of the piston, undergo an increase in kinetic energy, and hence alternative A is the correct choice.